Hello, Professor. This is Jason Koser doing my video summary for the early test. Let's get into it. So in exercise 1, we looked at prostate cancer study where we had multiple predictors that we were trying to predict the log antigens of the cancer. Don't fully understand the biology behind it, but understand the data and the analysis, that's for sure. So getting into it, we had 4 predictors, and we ended up finding that 1 was decent, 1 was really good, and we had 2 that weren't as good. They were more noise variables. And our MLR using all 4 predictors had a pretty decent, I would say. R squared of around like 0.6, getting close to that. And just going through here, some of the big points were the residual versus fitted graph had things close to the middle, so something we had to worry about was it might not have constant variance, which gives some of our values a little less reliability, but it wasn't too bad. And then we also looked into, because we're doing MLR, we needed to look into the multi-collinearity. We found slight correlations between some of the variables. The highest I found was between LBPH and L weight. They had a correlation of 0.435, which isn't terrible, but I personally concluded that, especially since we weren't even using them as they weren't the good variables, it mattered less. And I think we were good there with the multicollinearity, but it's important to check. Otherwise, those variables won't really be helping the model as much, and they could be, you might want to remove one of them or combine, or there's a few different steps that we could use to help with that. Getting into exercise 2, we looked at the polynomial growth model. We started out with an SLR though, looking at the growth of a bacterial colony. This one I understood a little better, the biology behind, because as there's more bacteria, they multiply, right? So as you get more bacteria, they're going to grow quicker. So you would expect it to be polynomial growth. But we started with simple linear regression, and we found that it had a pretty good R squared. But something important to note is when you look at the residual versus fitted, especially, it gave us like a U shape, which shows that definitely not linear, which means that the values that we got were pretty unreliable. Had to try something else. And because of the U shape, the next step you would go to would be a polynomial model. So we fitted it into a polynomial model, and very, very good results from this one, getting almost 1 for our R squared, which is I think the best I've ever seen for a model that I've made. But it makes sense because it's very expected based on the biology. There's not that much variance going on with bacteria growth, I assume. That's just, they're doing their thing. Nothing really stopping the bacteria from being consistent. But towards the end, the one thing that we did look into is that linear models are nice because they're easy to interpret. When you get to the polynomial model, it's starting to become a little, you gotta plug in the math if you want to interpret certain values, and as you get further away from the sample data, you can start getting more and more inaccurate because of the the growth of the model itself. And if you aren't perfectly fit, which you're never perfectly fit, you're going to get errors. And as your model is more, as like it grows really big, like polynomial growth does, you're more likely to get larger errors further away from the data. But yeah, overall, I think it was a good analysis of a few different models that we went over. The important things to note when you're looking at the models. Thank you for taking the time to listen to my video.